হ্যালো এভরিবডি, শুরু করছি আমাদের রিয়েল অ্যানালাইসিস থেকে লিমিট অ্যান্ড কন্টিনিউটি চ্যাপ্টারের থার্ড লেকচার। আগের লেকচারে আমরা লিমিট সম্বন্ধীয় কিছু তাদের অ্যালজেব্রা রিলেটেড কিছু থিওরাম ডিসকাস করেছিলাম। আজকের লেকচারেও আমরা সেই সব অ্যালজেব্রা রিলেটেড কিছু থিওরামস নিয়ে কন্টিনিউ করে যাব। তো এই ভিডিওটা যদি তোমাদের পছন্দ হয়ে থাকে প্লিজ লাইক করো এবং আমার এই চ্যানেলটাকে সাবস্ক্রাইব করো। আর যদি মনে হয় যে এই ভিডিওটা বন্ধুদেরও উপকার করতে পারে তাহলে প্লিজ তাদের সাথে একটু শেয়ার করো। তাহলে সময় নষ্ট না করে আমি ডক্টর অনিরুদ্ধ পালিত শুরু করছি রিয়েল অ্যানালাইসিস থেকে লিমিট অ্যান্ড কন্টিনিউটি রিলেটেড লেকচার 3। Here we are going to prove the result that when f and g are two real valued functions defined on an interval containing a small number containing a constant number small a as an interior point and limit extending to a fx and limit extending to a gx, both of these two exist. Then limit extending to a fx into gx, this limit exists, and this product limit of this product function is equal to the product of their limit. That means this is equal to limit extending to a fx into limit extending to a gx. In order to prove this result, what we need to do, we first assume that limit extending to a fx is equal to L and limit extending to a gx is equal to M. And we now apply the previous results along with the epsilon delta definitions. We can say that for each epsilon greater than 0 there exist 4 numbers, delta 1, delta 2, delta 3 and delta 4, such that modulus of fx minus L is less than k into epsilon. Now what is k? K is a certain arbitrary positive number, and because of that arbitrariness we shall use the value of k in order to finally obtain the existence of the required result. Anyway, so let's continue. Over here fx minus L is less than epsilon into k when 0 less than x minus a less than delta 1. Modulus of gx minus m is less than k into epsilon when 0 less than modulus of x minus a less than delta 2. And we've already proved previously the result that modulus of L by 2 is less than modulus of fx is less than 3 by 2 to modulus of L when 0 less than modulus of x minus a less than delta 3. And similarly for the function gx we have modulus of m by 2 less than modulus of gx less than 3 by 2 modulus of m in another neighborhood, say suppose delta 4 neighborhood, related delta 4 neighborhood of the point x is equal to a. Then all these 4 results must be true. Where k is an arbitrary quantity, we shall choose this quantity later on for our convenience. We now consider delta is equal to the minimum of all these delta 1, delta 2, delta 3 and delta 4. And as because all these quantities, all these delta 1, delta 2, delta 3 and delta 4, these are positive, therefore we can say that delta is a positive number. And as because delta is the minimum, therefore if x lies in this delta neighborhood of the point x is equal to a, then x must also lie within delta 1 neighborhood of the point a, within delta 2 neighborhood of the point a, within delta 3 neighborhood of the point a, and within delta 4 neighborhood of the point a. And therefore these inequalities on the right hand side, these inequalities on the right hand side, all these inequalities must be true. And as because these inequalities on the right hand side are true, therefore we can say that these inequalities of the left hand side are also true when x lies within the smaller delta neighborhood of the point x is equal to a. And therefore we get the result that when x lies within this smaller delta neighborhood of the point x is equal to a, therefore all these 4 inequalities are true. We mark them as equation number 1, 2, 3 and 4 respectively. Therefore what we can say that this function fx, our target is to prove that limit of the function fx into gx is equal to L into m. So we start with this result that the function minus the limit, this difference can now be written as fx minus L into gx plus L into Gx minus M. So this over here, this is actually the first term, this is the second term. So this is actually can be written as this modulus of this sum of these two terms can be written as modulus of first term, and that is this is equal to modulus of second term. You see, this first term is actually the product of two quantities. So this first term, modulus of first term, can be written as modulus of fx minus L into modulus of Gx. Similarly, modulus of second term can be written as modulus of L into modulus of Gx minus M. And therefore, this modulus of fx minus L can be written as k into epsilon. And over here, we have already proved that modulus of fx minus L is less than k into epsilon from equation number 1. And similarly, from equation number 2, we can prove that this modulus of Gx minus M, that is also less than epsilon. Over here, modulus of Gx is less than 3 by 2 into modulus of L. Therefore, we apply all these results and we get this expression over here. And this expression, from this expression, we can take this k into epsilon common. So within bracket, we will have this type of result when 0 modulus of x minus a less than delta. Now we apply the arbitrariness of the quantity k, as because k is arbitrary and you see this quantity is not equal to 0. Therefore, we can say that at least both m should be not equal to 0 and L should be not equal to 0. Therefore, we can say if we consider k is equal to 1 by this quantity, 1 by this much quantity, then the right hand side would be equal to epsilon. And therefore, we can say that modulus of fx into gx minus L into m, that is less than epsilon, when 0 less than modulus of x minus a less than delta. And therefore we can say that the epsilon delta definition for the existence of the limit is satisfied, and so we can say that modulus limit of the function fx into gx, this limit exists, and this limit is equal to L into m, and L is equal to limit extending to a fx, and m is equal to limit extending to a gx. And so we can say that yes, over here the limit of this product function is equal to the product of the individual limits, provided they exist. Over here, we should note that this much portion is we can omit the choice of the number k, because if by chance we forget to write k from the beginning, then we would not get this kind of k over here. However, this much quantity is a finite quantity and epsilon is a arbitrary small number. So altogether, this right hand side remains an arbitrary small number, and therefore we can say that the left hand side, that means this function fx into gx minus the limit L into m, this difference, modulus of this difference, always remains smaller than an arbitrary small number, and this much is sufficient to conclude that limit extending to a fx into gx exists and is equal to L into m. So this is also then can be used to prove this result. Now we prove another theorem. Over here we are considering the division of these two functions, but in order to prove this division, we need to consider the existence of these two limits, along with the fact that limit extending to a fx should be not equal to 0. So over here f and g are two real valued functions defined on an interval containing small a as an interior point, and both of these two limits of the function f and g as extending to a exist, and the limit of the second function gx is not equal to 0. In that case, we can prove that limit extending to a fx divided by gx, this division exists, this limit exists, and this limit is nothing but is equal to limit of first function divided by limit of second function, provided the limit of the second function is not equal to 0. What we are doing over here, just like previous theorem, we consider the limit of the function fx is equal to L and limit of the function gx is equal to M, and from the definition there exist for each epsilon there exist 4 delta 1 delta 2 delta 3 delta 4 such that all these results hold. And as because over here M is not equal to 0, therefore additionally we can say that modulus of M by 2 that is greater than 0. Now we consider delta is equal to minimum of all these delta 1, delta 2, delta 3, delta 4, and therefore we can say that these 4 left hand side inequalities they also hold when x lies within the smaller delta neighborhood, and therefore we can write this expression. Our target is to prove that fx limit of the function fx by gx, then that is equal to L by M. So we start with the difference function minus limit and its modulus, and this can be written after taking the LCM modulus of gx into M. This can be written as modulus of M into fx minus L into gx, and we now adjust them by writing fx minus L. We need to keep in mind that L should be written with fx because fx is converging to L, therefore this quantity is less than epsilon. Similarly, G should be written with M because Gx is converging to M, and therefore this quantity should be smaller and smaller quantities. And this left hand side modulus, this expression can be written as modulus of this first term, that is actually modulus of M into modulus of fx minus L. Similarly, the modulus of the second term is equal to modulus of L into modulus of gx minus M. This expression, as because M is not equal to 0, therefore we can keep it over here modulus of M, and this gx can be written as 1 by modulus of gx. And you see that this expression over here, this is less than epsilon, this quantity is less than epsilon, k into epsilon, this fx minus L is less than k into epsilon, this quantity is also less than k into epsilon. And what about this 1 by modulus of g? Over here you see that modulus of g is less than epsilon, and so we can say by considering the inverse 1 by modulus of g of x, this quantity, and just consider the cross product, this quantity should be less than how much? That quantity should be less than 2 divided by modulus of M. When 0 less than modulus of x minus a less than delta. And hence we can say that 1 by modulus of gx is less than 2 by modulus of M, and so we can say that 1 by modulus of gx is less than 2 by modulus of M when 0 less than modulus of x minus a less than delta. And therefore we can say that this expression, this much expression, if we consider this k into epsilon common from these expressions, we can say that this left hand side expression modulus of fx minus modulus fx by gx minus L by M, that quantity should be less than this k into epsilon. After taking this common, this quantity should be twice k epsilon into modulus of M plus modulus of L divided by modulus of M squared. And as because this quantity is not equal to 0, so M over here, M is not equal to 0, therefore this quantity is also not equal to 0. So if we consider k as the inverse of this expression, that means k is equal to M square divided by this 2 into this expression, we can then would be able to write this left hand side as less than epsilon when 0 less than modulus of x minus a less than delta. And therefore we can say that the limit of the function fx by gx exists and is equal to L by M. And so this L by M can be written as limit of fx divided by limit of gx. Therefore this completes the proof. We now keep one result as a homework. But before that, we need to consider this kind of example that you see, we can't say that limit extending to a is equal to limit extending to 0 x sine of 1 by x is equal to limit extending to 0 x into limit extending to 0 sine of 1 by x, because later on in our subsequent lectures we shall prove that limit extending to a sine of 1 by x, this limit does not exist. And as because it does not exist, we cannot write this left hand side limit as the product of these two limits. I am keeping one result as a homework, that if limit extending to a gx is equal to m and this m not equal to 0, then limit extending to a 1 by gx is equal to 1 by m. Over here m is not equal to 0. এই রেজাল্টটা আমি হোমওয়ার্ক হিসেবে ছাড়ছি। এখানে আমাদের এর পরবর্তীতে আরো কিছু রেজাল্ট নিয়ে আমরা ডিসকাস করব। আজকে এইটুকুই থাকুক। ভিডিওটা যদি পছন্দ হয়ে থাকে তাহলে তোমরা প্লিজ লাইক এন্ড শেয়ার করো, বন্ধুদের সাথে এটাকে শেয়ার করো এবং আমার চ্যানেলটাকে সাবস্ক্রাইব করো। তোমাদের কোনো কমেন্ট যদি থাকে তাহলে আমাদের কমেন্ট বক্সে জানাও। আমরা এখানে আমাদের কমেন্টগুলো যদি আমরা ঠিকঠাকভাবে পাই তাহলে আমি পরবর্তী যে ভিডিওগুলো আছে সেই ভিডিওগুলোতে আমি সেই কমেন্টগুলো বা কোশ্চেনগুলো যদি থাকে সেগুলো নিয়ে আমরা ডিসকাস করতে পারবো এবং আমাদের ডিসকাশনটা কন্টিনিউ করে যেতে পারবো। আজকে তাহলে এইটুকুই থাকুক। থ্যাংক ইউ।